Let's see if we remember our exponent rules. They don't have to be in any specific order. Give me a rule. Any rule. Anything to the 0 power is equal to 1, except 0. Give me another one. Negative exponent, you flip it. Okay, make the exponent positive. What's another rule? Adding. So when do you add them? So if it's x to the a times x to the b, you're going to add the exponents. When do you multiply the exponents? When it's x to the a raised to the b, then you multiply. So when you have powers raised to powers, you multiply. What are the other rules we had written down? There's 2 more. We had a 5 and a 6. Anybody remember? They're kind of similar. Come on. If you have 2 things, x times y, and those 2 things are raised to the a, what has to happen? They both get raised to that power. Okay? And then what was the 6th one? What do you do with x divided by y raised to the a power? xa over y to the a. So again, they both get raised to that power. Today we're mainly talking division. So we're going to add one more rule to this. So what do you do? If you have, let's go numbers, 2 to the 4th times 2 to the 3rd. What do we do with those exponents? You add them. Why? Why is this 2 to the 7th power? Because this means 2 times 2 times 2 times 2, right? And this means times 2 times 2 times 2. So you got 4 2's and you got 3 2's, right? But really, it's all multiplication. And what do you end up with? You end up with 7 2's, right? So if that's the case, what do you think you're going to do if you have 2 to the 5th power divided by 2 to the 3rd power? What's the guess? You subtract? So you think the answer here is 2 to the 2nd power? Well, what does 2 to the 5th power mean? It means 2 times 2 times 2 times 2 times 2 divided by this 2 to the 3rd means 2 times 2. What do you think happens with these 2 2's? They cancel. So those cancel, and those cancel. What are we left with? 2 2's. So yes, the next rule is actually pretty simple, and it kind of makes sense with this one. If you see 2 numbers with the same base raised to powers where you multiply, you're going to add the exponents, right? What do you think the rule is for rule number 7 then? If you see x to the a over x to the b, you're going to subtract a minus b. Now, that rule actually can get used a couple different ways. This is a rule that you technically could get away with without using the rule. And here's what I mean. You just have to use 2 different rules. Would you agree that 2 to the 5th power divided by 2 to the 3rd power, is this the same thing as 2 to the 5th power times 2 to the negative 3rd power? Are these two things the same thing? What would you do with negative exponents? You'd flip them. So wouldn't you put those 2 to the thirds in the bottom and then make it positive? These rules can actually be used backwards. So these two things are in fact the same thing, aren't they? But then rule number 2, or the exponents when we multiply, what does that tell us I should do with the 5 and the negative 3? It should add them together. And then isn't adding a negative the same as minusing? So this rule of division, where all you really have to do is 5 minus 3, it's actually kind of a combination of two rules that it's kind of one of those rules that technically we could do without by using two rules, but they basically took two rules and made one rule to make our life a little bit easier. Does that kind of make sense? Now, you do have to be careful because there's another way you can kind of think of this. What if you had 3 to the 7th over 3 to the 10th? What do you think you're going to do with those exponents? You're going to subtract. But you're going to get 7 minus 10, which is negative 3. Now what do you do with negative exponents? You flip them, which means 1 over 3 to the third. I don't actually like to use that rule that way. I know I'm going to subtract. If you really just think about what's happening here, where you have 1, 2, 3, 4, 5, 6, 7, and then you have 1, 2, 3, 4, 6, 7, 8, 9, 10, what are you just going to be left with? When things start canceling, what are you just going to be left with? I miscounted. There you go. When things start canceling, what are you just going to be left with is my question. 3 3s. But where are the leftovers going to be located? In the bottom, right? So I like to kind of think of it as, I'm just going to subtract. You can do 7 minus 10 or 10 minus 7. It doesn't really matter. As long as you understand where the leftovers are going to be. Are the leftovers going to be in the bottom, or are the leftovers going to be in the top? Does that kind of make sense? Kind of easy? Now, another type of problem that you can do that we can use our exponent property with, you know this rule where you have x over y to the a power equals x to the a over y to the a. This property, if you see 2/3 to the 4th power, yeah, one way to use this rule is to use it that way, where you go, that's the same thing as 2 to the 4th over 3 to the 4th, and then you can simplify that thing. 2 times 2 is 4, times 2 is 8, times 2 is 16. That'd be 81. One way is to do it that way. But there is another way to use this property, which is, what would you do if you had 4 squared over 6 squared? What do you notice about these two numbers? What do they have in common? Huh? They have the same exponent. All of these rules can actually be used in both directions. If you notice that these both have the same exponent, then that is the same thing as 4/6 raised to the 2nd power. So you can kind of undistribute, right? Where if you saw they were both raised to the 2nd power, you can say, all right, I'm going to put them both to that 2nd power and write it as a fraction. Now what can I do with that 4/6? I can reduce that, can't I? What does 4 over 6 reduce to? 2/3. And then I could put that back together, and I can say, all right, that's the same thing as 2 squared over 3 squared, which is 4/9. It is one way to simplify fractions. Yes, is another way to do this, what is 4 squared? 16. What is 6 squared? 36. Do you think that 16 over 36 reduces to 4/9? Yes, it does. Either one of these methods is a way to reduce fractions with exponents. Basically, what I would say is look for things in common. If you see that two numbers have the same exponent, figure out a way to use that. Can I use the fact that they are both raised to the same power? That might help us simplify some things. Okay? What do you think we would do if you had 2a to the third b squared over 4a squared b to the fifth? If this was a quiz question, what's the first thing you'd want to take care of? Top? What would you do to the top? Raise everything to that second power. So the 2, the big 2, that has to get raised to the second power. The a to the third has to get raised to the second power. And the b squared has to get raised to the second power. In other words, what would you have in the top? 4, a to the sixth, b to the fourth, over, all right, I would just have this, wouldn't I? 4a squared b to the fifth. But this can be simplified, can it? What do you think happens to my 4's? They're gone. 4 divided by 4 is 1. That's just gone. So these go away. What happens to my a's? How many a's would I be left with? 4. And would they be left over in the top or the bottom? So the 4's are gone. I'd have a to the fourth on top. What's going to happen to my b's? How many leftovers am I going to have when I subtract? 1. And where is that leftover going to be located? In the bottom. This is what your answer would be. A to the fourth just over b. Easy stuff? That's really all the new stuff that we have to do today. But what it also, this rule allows us to do, if I gave you this problem, what do you think an easy way to handle this would be? Put them both in scientific notation. This would be 8 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 divided by, this would be 2 times 10 to the 1, 2, 3, 4, 5. What do you think I'm going to do with that 8 and the 2? Divide them. What's 8 divided by 2? 4. What am I going to do with the 10 to the 8th divided by 10 to the 5th? Subtract the exponents, which now means 10 to the 3rd. So the answer would be, 1, 2, 3, 4,000. Using scientific notation with division also allows us to handle those big giant numbers or really small numbers where you now are just going to subtract those. So using these exponent rules with scientific notation makes life a lot easier because you don't have to worry about all of those extra zeros. We're basically just doing 8 divided by 2. I knew the answer was going to be 4. It's just a matter of how many zeros. And then we basically just subtract the exponents. What would happen if you had 160,000 divided by that. Well, this into scientific notation would be 1.6 times 10 to the 1, 2, 3, 4, 5 divided by, this would be 2 times 10 to the 1, 2, 3, 4, 5, negative 6. What's 1.6 divided by 2? Is it 0.8? Yep. So we got 0.8 times 10 to the what? What do you do with the 5 and the negative 6? Division means you should subtract. What is 5 minus a negative 6? 11. Which means I got to take that 0.8 and move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. And there's your answer. Put some commas in there. 80 billion, something like that. Make sense? Easy stuff? All right, everybody take a look at page 471. Let's try a few of these together. 471. We'll start your homework. Might as well take out a sheet of paper and we're just going to start the homework together. Number 3 says 15x to the 6th over 5x to the 6th. What do you do with the 15 and the 5? What should happen with the 15 and the 5? 3. They just reduce. 3 over 1. What happens with my x to the 6th and x to the 6th? Don't they just cancel? What's the answer to this question? 3. There's no x's left over. Everything cancels. All right. Number 6. What's number 6 say? Oh, that's scientific notation. 5.5 times 10 to the 3rd. Divided by 5 times 10 to the 8th. What do I do with my 5.5 and my 5? Divide. What is 5.5 divided by 5? 1.1. Times 10. What do I do with the 3 and the 8? So I get negative 5. And then I would just say 1.1, 1, 2, 3, 4, 5. So it's going to have 4 zeros. 0.4 zeros, 1, 1. All right, what's number 9? It says 2/5 squared. What's the answer? Four? What? 25ths? 4 over 25? Easy enough. Let's try number 12. What do you do with y to the 10th over y? What's the exponent in that denominator? The y to the... This would be a 1, right? So you just subtract, and the answer is y to the 9. Really is that easy. How about number 15? 15 says 2/3 raised to the -1 times 3 over 2, 3a over 2b raised to the -2. What do you think? Sure. What's the first one mean? What does this 2/3 to the -1 mean? What's going to happen with this 2? It's going to get raised to the -1, which means I have to put it where? In the bottom. What's going to happen to this 3? It's going to get raised to the -1, which means it has to move to the top. And then they're both going to be raised to the 1 power, which means this 2/3 to the -1 just means it flips upside down. What's going to happen over here? What does this negative mean? Everything inside is going to have to get flipped. So all these go to the top, all those go to the bottom. And these are raised to the 2nd power, which means this 2 has to turn into a what? So I'm going to have a 4 and a b squared on top. Yes? And what am I going to have in the denominator? 9 a squared. Am I done? What should happen with this 3 and 9? Could I reduce that? That would just turn into a 1. That would turn into a 3. This 2 and 4 should reduce to 1 and 2. So what do I have left? What's my final answer here? What do I have in the numerator? I have a 2 and a b squared. And what do I have in my denominator? A 3 and a squared. And there's your answer. How are we feeling with this stuff? Good, bad, indifferent? Okay.